Hey everyone, Mr. Herc here, and today we're going to be going over the AP Precalc 1.1 to 1.3 quiz review. Let's get right into it. All right, so number one, the table shows values for function h at selected values of x. Which of the following claims and explanation statements best fit this data? So here we want to see first, is it linear or quadratic? And then we want to match the correct answer choice that correlates with the correct answer. So let's take a look at how our x and our y values are changing to determine whether a function is linear or quadratic. Here, if we take a look at our x values, from -7 to 1, this is plus 8, 1 to 9, plus 8, 9 to 17, 17 to 25, also plus 8. So here we see our x values, our inputs, are equally spaced, right? It's the same number going across. You'll typically see this whether it's linear or quadratic, but it's just good to make sure as of right now. We'll get to situations where that's not going to be the case later on this school year. Now let's take a look at our y values. From 5 to 7, we have plus 2, 7 to 9, 9 to 11, 11 to 13. Here we see this is what we call our first differences, which is also known as our average rate of change or rates of change. Here, this is constant, or are constant, depending on how you phrase it. And the reason for that is because they're the same number. They're the constant number of plus 2. So when the first differences are constant, then the first differences are constant, sorry, that means that it should be a linear function. So we can eliminate C and D because we know it's not quadratic. Knowing that, to determine between A and B, what explanation is true? This is linear because the average rates of change, or the first difference, is constant, making A the correct answer. Now, in the case where it was quadratic and the second differences are constant, when you go like one step deeper, then it would be D if it was quadratic because the average rates of change is linear. But this equation is linear, so the average rates of change is constant there. So don't get confused. It will never be B or C in this case because of the fact that the explanations just match the wrong function type. All right, number 2, here we have the graph of f. On which of the following intervals is f decreasing and concave down? We're talking about the function for both of these, so we just want to see where is it decreasing and then concave down. Well, I know it's decreasing from A to B and from D to E. And then I also know it's concave down from C to E as well. So the only portion of that graph where it's both of those, both red and blue, would be from D to E. So that should be our answer here. The interval from D to E is where it is both decreasing and it's also concave down. All right, number 3, of the following points, A, B, C, and D, where is the rate of change least? The least, which means the lowest number. Taking a look at these 4 points, A, B, C, and D, remember rate of change is just another word for slope. So we're looking at the slope of these lines here. Let's take a look. A here is increasing on that line, so we know the slope should be positive. B, it's going down, so that should be a negative slope. C as well should also be a negative slope. And then D is flat. It's at the top or the very bottom, which means the slope should be 0. Because of this, we now know the lowest numbers will be either B or C because they're both negative. So we can eliminate A and D. A 0 and a positive will always be bigger than any negative number, so A and D are out. Now between B and C, how do we know which one's the lowest value without being able to find the exact slope? Well, we kind of just have to look at the steepness of each line and maybe do a little bit of guesstimation. Taking a look at this, here, B, we could say maybe might have a slope of, let's say, -1, right? It looks like a nice 45-degree angle. C is a little steeper. Let's say C has maybe a slope of -2. In this case, C should be less than B because a slope of -2 is going to be obviously less than a slope of -1. So the rate of change of C is going to be less than the rate of change of B. Now, I want to make it very clear that it is not important on what your exact numbers are, right? You could say, you can make the case for B to be negative 1/2 and C to be -1, or whatever the case may be, as long as you know how they compare relative to one another. For example, as long as you know C is going to be steeper in the negative direction, then no matter what your guesstimations are, as long as they're, somewhat correct, C should always be lower, a lower number, than B. So here C should be our correct answer, because that is where it is the lowest number. The rate of change is the least. All right, number 4. Which of the following best describes the graph shown above? Well, we want to know, is the function increasing or decreasing first? Here, this function is going up, so this function should be increasing. We can eliminate C and D right off the bat. Then the next portion of this question is asking, is the rate of change, the ROC, increasing or decreasing? That is going to always be tied to concavity. So here, when a graph is concave up, which is what this graph is, that always means the rate of change will always be increasing, making A the correct answer for number 4. If it was concave down, the rate of change would then be decreasing. All right, number 5. The function f is defined for all real numbers. The table gives values of f of x at selected values of x. Based on the table, what function type best models this function, linear or quadratic, and then give a reason for your answer, right? So first off, let's figure out what is this function. Well, looking at our x values, here we see from -2 to 1, it's not 1 or -1, it's +3. 1 to 4, +3, 4 to 7, and then 7 to 10. Those are all +3. So we see our x values, our inputs, are equally spaced. This is a good sign. This is kind of like a litmus test for linear quadratic, and you'll see it for either one. So we don't know which one it is yet. Looking at our y values, our outputs. Here, be really careful with your addition and subtraction. From -20 to 30, this is not 10 or -10, this is +50. 30 to 50 is +20. 50 to 40 is -10. 40 to 0 is -40. So make sure you have those numbers correct, right? If one or two numbers are off, the whole thing is just kind of messed up. Looking at this, from 50 to 20, positive 50 to positive 20 is -30. From 20 to -10 is also -30. And then -10 to -40 is also -30. Here we see that this is the first difference, and then this right here is the second difference. We see the first difference is not the same, it's not constant, but the second difference is constant. And the second difference is constant of -30. When the second difference is constant, that means it is always going to be a quadratic function. So for part 1, all we literally have to write is just the word quadratic, right? Answer the question. Part 2 is where we give our reasoning and explanation. So taking a look at this, we want to talk about 3 things, and all 3 things are things that I will be looking for. If you don't have them, you will get points deducted for this question. We need a change in the outputs, which is our y values, the change in the inputs, which is our x, and then we need to refer to values in the table in our reasoning. Taking a look at this, I would say I would always start with this phrase, which is over equally spaced inputs. And this will talk about our x values, our change in the inputs. So this kind of covers that. So let me just mark that off. There we go. Over equally spaced inputs, the outputs have a second difference. And here, now we've talked about the change in our outputs. So that's that portion of the answer right there. The outputs have a second difference, and now we need to refer to values in the table in our reasoning. And what's the best way to do that? We just want to show that we didn't just memorize a cookie cutter answer, and we actually did the math and looked at the table. So really what they want is a second difference of minus 30. They want that number there to show that you actually did the math to find that second difference. That we'll talk about. That covers the refer to the values in the table in your reasoning. And this would be a perfect answer for a part 2 of this type of question. Now, if it was linear, you would say pretty much the exact same thing over equally spaced inputs. The outputs have, and then you would say first difference of, and then whatever it is, meaning if it's linear, those numbers would all be the same. There would be no reason to find a second difference at that point. All right, number 6, the graph of h of t is shown above. 5 points are labeled. We're looking from G to J. So let's look at this here, G to J. And I'm going to draw this portion of the graph out and label it. So we have -5 to +8, and then 0 to 4. This will span y values from 8 to 4. Which of the following is true? Is this function positive or negative, and increasing or decreasing? Well, this function is completely above the x-axis here, right? If we were to actually graph this, and here, like obviously the x-axis will not be drawn. It's not going to be any one of these 3 lines automatically. It could be in some situations, but in this case it's not, right? The x-axis would fall below this portion, but this entire portion of the graph is positive y values. That's why we looked at those. So this should be h is positive, the function is positive, and now, is the function increasing or decreasing? Well, this is pretty easy, right? This portion of the graph is decreasing because it's going down. So B should be our correct answer. On your quiz, you can just circle the letter B or write B to the side, right? As long as I know what answer choice you're selecting, that's really all that matters. Now for part 2, on the interval from T1 to T2, describe the concavity of H and determine whether the rate of change is increasing or decreasing. Now, like I said before in the lesson video, you need both parts. If you miss one of the parts, you will get points deducted. You may only get half credit for this question, and that sucks because if you get one part right, you should get the other part because they kind of go hand in hand. So looking at this portion of the graph, we see that this is actually going to be concave up because it's a part of an upwards U shape. So I'm going to say H is concave up. That's half of it right there, right? So you already did the hard part by finding the answer, and now you just have to put the answer that kind of ties with that. So whenever H is concave up, and it doesn't matter what the graph looks like, if it is concave up, then we automatically know the rate of change of H is increasing. And that covers this part right here. So you covered both of those parts. You do need both of these parts to get full credit for part 2. Just know that they will always go hand in hand. So concave up means the rate of change is increasing. If it is concave down, the rate of change is decreasing. I remember down and decreasing both begin with the letter D. All right, if you have any questions, please come see me in office hours before the quiz, and I will see you guys later. Thanks.